Hi everyone, this is our presentation on cyanide from Group 15 by Michelle Ng, Ryan Lee, and Jennifer Nguyen. Despite having a reputation for being an extremely toxic chemical, cyanide is actually one of the most common chemicals in the world. Common names include formylnitrile, hydrocyanic acid, or prussic acid. Cyanide's appearance is a colorless or pale blue liquid below 78 degrees Fahrenheit and a colorless gas above 78 degrees Fahrenheit. Hydrogen cyanide is commonly known as a systemic chemical asphyxiant, which means it interferes with the normal oxygen consumption of nearly every organ in the body. It particularly has extreme effects on organ systems most sensitive to low oxygen concentrations, such as the central nervous system, cardiovascular system, and pulmonary system. Cyanide was discovered in 1782 by a Swedish chemist by the name of Carl Wilhelm Scheele while preparing it from the pigment Prussian blue. Historically, hydrogen cyanide has been used as a chemical warfare agent. The use of cyanide in the war effort goes back to the Franco-Prussian War from 1870 to 1871. During this war, Napoleon III proposed for his troops to dip their bayonets in the poison. Previously, Roman Emperor Nero also used cyanide containing cherry laurel water as a poison. Furthermore, both world wars include the use of cyanide. During World War I, the French and Austrian troops engaged in the use of cyanide. In World War II, Nazi Germany used cyanide in the form of rodent poison to annihilate millions. In the 1980s, cyanide was used in the Iran-Iraq War on the Kurds in Iraq and Syria. In 1995, a Japanese cult by the name of Shinrikyo placed cyanide in subway bathrooms. Throughout history, cyanide has been a repeated weapon of terrorism. When isolated, cyanide is a linear anion consisting of a single carbon atom and a single nitrogen atom bound with a triple bond. The nitrogen atom in cyanide acts as a strong nucleophile and weak base in reactions. Therefore, it is not very reactive in E1 and E2 reactions, but can participate in SN1 and SN2 reactions. Hydrogen cyanide is an unstable chemical when mixed with heat, alkaline materials, and water, and will react with amines, oxidants, acids, sodium hydroxide, calcium hydroxide, sodium carbonate, caustic substances, and ammonia. Hydrogen cyanide mixes well with air, which can easily form explosive mixtures. The fires produced from cyanide explosions will result in irritating, corrosive, or toxic gases. The vapors of hydrogen cyanide are highly toxic and a poisonous hazard. The hazardous levels of hydrogen cyanide can develop rapidly in enclosed environments and poorly ventilated areas.
Next, we will be discussing the chemical synthesis of cyanide. Although cyanide was discovered in the 18th century, it was not until the 1900s when cyanide was able to be synthesized by the Androsso process. The Androsso process was developed by German chemist Leonid Androsso and is the primary way we synthesize cyanide today in the form of hydrogen cyanide. The Androsso process is a series of chemical reactions that involves methane reacting with ammonia and a platinum catalyst under aerobic conditions to produce hydrogen cyanide. After a series of purification steps, it can be then utilized for industrial use. Although cyanide has numerous uses in industry, it is hazardous and can cause a number of complications. Cyanide poisons the mitochondrial electron transport chain within cells, which prevents aerobic respiration. This means that cell will be unable to produce ATP from oxygen. Cyanide is able to produce this effect by binding to complex 4 of cytochrome oxidase, ultimately preventing cells from utilizing oxygen in ATP production. This will ultimately cause rapid cellular death, as much less energy is produced within the cell. In large doses, cyanide quickly binds with iron in cytochrome 3, preventing electron transport within the cytochrome. This stops oxidative phosphorylation and ATP production. As a result, intracellular oxygen utilization ceases. Cells are then forced into anaerobic metabolism, creating lactic acid and leading to acid-base imbalances and metabolic acidosis. In small doses, cyanide can be metabolized into thiocyanate with assistance of the hepatic enzyme rhodinase. Thiocyanate is then excreted in urine. A small amount of cyanide can also be converted to carbon dioxide, which leaves the body through exhalation. Last, small quantities of cyanide can also react with hydroxycobalamin to form vitamin B12. Cyanide also has a number of unique qualities. For one, it can take the form of a colorless gas or a white water-soluble solid crystal. On the other hand, it is also characterized to have a bitter almond aroma. The safety data sheet for hydrogen cyanide states that hydrogen cyanide may be corrosive to metals and is fatal if swallowed, inhaled, or in contact with skin. In addition, it can cause damage to organs through prolonged or repeated exposure, and it is very toxic to aquatic life with long-lasting effects.
As previously discussed, in the past, cyanide has been used as a chemical weapon in the form of hydrogen cyanide gas. The French military first used it during World War I, and other countries like Germany also used it during World War II. While it does have a reputation for being lethal, cyanide can also be used in other contexts. It can be used in the manufacturing industry for things like textile dyes. And cyanide salts are also used for electroplating, metal cleaning, and the gold extraction process. Moving on to the effects of cyanide on humans, the three main routes of exposure include inhalation, ingestion, and absorption. Usually, the extent of cyanide poisoning depends on a lot of factors, including the amount, route, and length of time a person is exposed. But research has shown that breathing in cyanide gas causes the most harm because it prevents the heart and the brain from using oxygen, which results in cell death. In most cases, cyanide exposure isn't intentional. Most of the time, people are exposed to it by eating fruit seeds, smoking cigarettes, inhaling smoke from a house fire, or burning plastic or coal. If an individual is exposed to cyanide for only a short amount of time to a small amount, common symptoms include dizziness, headaches, nausea, rapid breathing and heart rate, and weakness, while long-term exposure symptoms include convulsions, loss of consciousness, low blood pressure, respiratory failure, and a slow heart rate. So in the case of cyanide exposure, there are three main ways to treat it. First, if exposed to only a small amount, it can be eliminated through the body through natural processes like sweating. In a more serious case, however, it can be treated with rapid oxygen administration or sodium nitrite. Sodium nitrite forms methemoglobin, which then attracts cyanide away from the cytochrome A3 of complex 4. This allows for the electron transport chain to function again and produce ATP. If sodium nitrite is unavailable, amyl nitrite can be administered instead by inhalation. It will have the same mechanism of oxidizing hemoglobin into methemoglobin. Lastly, sodium thiosulfate could also be used to treat exposure. It provides the sulfur source necessary for the enzyme rhodinase to accelerate the conversion of cyanide into the less toxic version that is thiocyanate. And that's all for our presentation. Thank you for listening.